Hello and welcome to The Dreamy Physicist. I'm so glad you're here. Whether you're settling in for the evening, curling up with a cup of tea, or just trying to let your mind wander after a long day of being wonderfully, exhaustingly human, you've found the right place. This is our quiet corner where physics gets a little softer around the edges, where the universe reveals its secrets in whispers rather than shouts, and where the impossible becomes not just possible, but oddly comforting. Tonight, we're embarking on a journey into one of the most mind-bending ideas in all of science. We're going to explore parallel worlds, quantum decoherence, and the hidden multiverse that might be unfolding right beside you at this very moment. It's a story filled with splitting realities, invisible neighbors, and the strange quantum dance that determines which version of the universe you happen to experience. Now, I do hope this exploration isn't so fascinating that it keeps you awake, but if it does, at least you'll be pondering some of the deepest mysteries of existence. Before we drift into these parallel realms, if you enjoy these gentle explorations of the cosmos and you'd like to help this little channel grow, I'd be ever so grateful if you tapped the like button, subscribed, or simply left a comment telling me where in the world you're listening from and what version of reality brought you here tonight. So take a deep breath, settle in, and let's begin our quiet voyage into the many worlds that might exist beyond the veil of our everyday experience. What if I told you that right now, as you listen to these words, there might be countless other versions of you living out slightly different lives in parallel universes? In one world, you chose tea instead of coffee this morning. In another, you took a different route to work. In yet another, you decided to learn the violin instead of the guitar, or perhaps you never moved to the city where you now live. These aren't flights of fancy or the musings of science fiction writers, though they've certainly captured imaginations for decades. They're serious possibilities emerging from our best understanding of quantum mechanics. The idea sounds almost absurd, doesn't it? Multiple realities branching off from every quantum event, every moment of uncertainty, every time the universe faces a choice between different possibilities. But this concept, known as the many worlds interpretation of quantum mechanics, has been quietly revolutionizing how physicists think about reality since the 1950s. It's elegant, it's mathematically consistent, and it might just be true. At its heart lies something called quantum decoherence, a process so subtle and swift that it happens trillions of times per second all around you, yet remains completely invisible to your scoherence is the mechanism mensis. That might explain how our single, coherent quantum universe splits into multiple parallel realities, each one as real and complete as the one you're experiencing right now. To understand how this works, we need to start with the strange world of quantum mechanics itself. In the quantum realm, particles don't behave like the solid, predictable objects we're used to. Instead, they exist in what physicists call superposition, a ghostly state where they can be in multiple places, have multiple properties, or follow multiple paths simultaneously. It's as if reality itself can't make up its mind until someone or something forces it to choose. Picture an electron orbiting an atom. In our everyday thinking, we might imagine it following a specific path, like a tiny planet circling a miniature sun. But quantum mechanics tells us something far stranger. The electron doesn't follow any single path at all. Instead, it exists in a cloud of probability, simultaneously taking every possible route around the nucleus until something measures it and forces it to collapse into just one definite state. This superposition isn't limited to tiny particles. In principle, it applies to everything in the universe, from atoms to molecules to theoretically even larger objects. The famous thought experiment of Schrödinger's cat illustrates this beautifully. A cat in a box with a quantum trigger that might or might not release poison exists, according to quantum mechanics, in a superposition of being both alive and dead until someone opens the box and observes the outcome. But here's the puzzle that has troubled physicists for nearly a century. If quantum mechanics is correct and superposition is real, why don't we see it in our everyday world? Why don't we experience cats that are both alive and dead, or objects that are in multiple places at once? Why does our reality seem so definite, so classical, so wonderfully normal when the underlying quantum world is so bizarre? The answer, many physicists believe, lies in quantum decoherence. This process acts like a cosmic referee, constantly forcing the quantum world to make choices and create the stable classical reality we experience. But here's where it gets truly fascinating. Some interpretations suggest that decoherence doesn't actually eliminate the other possibilities. Instead, it separates them into parallel branches of reality, each one evolving independently. Imagine reality as a vast tree, with each quantum event creating a new branch. Every time a particle's wave function collapses, every time the universe faces a quantum choice, reality splits. One branch continues with outcome A, while another branch splits off with outcome B. Both branches are equally real, equally valid, and equally populated with conscious observers who are convinced that their branch is the only true reality. In this view, decoherence isn't destroying alternate possibilities. It's organizing them, separating them into distinct, non-interfering worlds that can no longer influence each other. You experience just one branch of this cosmic tree, but countless other versions of you are experiencing all the other branches, each one slightly different, each one convinced they're living in the one true universe. The mathematics behind this idea is surprisingly elegant. When physicists calculate how quantum systems evolve over time, they find that the equations naturally lead to branching, splitting structures. The wave function, that mathematical description of a quantum system's state, doesn't collapse into a single outcome. Instead, it spreads out into multiple components, each representing a different possible world. What makes these worlds truly separate is their inability to interfere with each other once decoherence has occurred. In the early stages of a quantum system, different possibilities can still influence each other through quantum interference, creating those strange wave-like behaviors that make quantum mechanics so mysterious. But as the system interacts with its environment, as decoherence takes hold, these interference effects rapidly disappear. The different branches of reality become isolated from each other, unable to communicate or influence each other's evolution. This isolation is what makes the parallel worlds hidden from us. They're not in some distant dimension or alternate space. They're right here, occupying the same space as our world, but separated by the quantum equivalent of a one-way mirror. We can't see them, can't interact with them, can't even prove they exist, because decoherence has severed all the quantum connections that might allow communication between worlds. The speed at which decoherence occurs is staggering. For most everyday objects, quantum coherence is lost in tiny fractions of a second, sometimes in billionths or trillionths of a second. A dust particle floating in air loses its quantum coherence almost instantly due to collisions with air molecules. A bacterium maintains quantum coherence for perhaps a few femtoseconds before its complex internal structure forces decoherence. Even individual atoms in room temperature environments typically lose coherence in microseconds or milliseconds. This rapid decoherence explains why we don't see quantum superposition in our daily lives. By the time light from an object reaches our eyes, by the time our brains process what we're seeing, countless decoherence events have already occurred. The quantum fuzziness has been smoothed away, leaving us with the crisp, definite classical world we know and love. But the implications are profound. If the many worlds interpretation is correct, then every quantum measurement, every random decay of a radioactive atom, every quantum fluctuation in your brain as you think these thoughts is creating new branches of reality. The universe is constantly flowering into new possibilities, new worlds, new versions of history. Consider what this means for your own existence. Every quantum event in your body, every random molecular collision, every quantum process in your neurons might be spawning alternate versions of yourself. Most of these alternates would be virtually identical to you, differing only in microscopic ways. But occasionally, larger differences might accumulate. Perhaps in one world, a different pattern of neural firing led you to choose a different career. In another, a quantum event in your DNA during development gave you slightly different physical characteristics. The branching isn't limited to living things, of course. Every star in the sky, every planet, every galaxy is presumably splitting into multiple versions as quantum events unfold throughout the cosmos. The weather systems on Earth, driven by countless molecular collisions and quantum processes, are creating branches where storms follow different paths, where rain falls at different times, where the climate evolves along slightly different trajectories. Some branches might differ from ours in dramatic ways. Perhaps in one branch, a cosmic ray struck a crucial computer chip differently, leading to a different outcome in some important calculation. Maybe in another branch, a quantum fluctuation in the early universe led to stars forming in slightly different configurations, creating alternate versions of galactic evolution. The number of these parallel worlds is almost incomprehensible. Some physicists estimate that the observable universe might be splitting into something like 10 to the power of 10 to the power of 50 new branches every second. That's a number so large it defies intuition, a branching so rapid and extensive that it boggles the mind. Yet each of these branches feels completely normal to its inhabitants. In every world, conscious observers wake up each morning, convinced that their reality is the real one, that their history is the true history, that their universe is the only universe. They have no way of knowing about their countless, alternate selves living out slightly different lives in parallel branches of the cosmic tree. This raises fascinating questions about identity and consciousness. Are you the same person as your alternate selves in other branches? Do you share some fundamental identity with them, or are you completely separate beings who who just happen to share a common origin. If consciousness can exist in multiple branches simultaneously, what does that mean for the nature of self-awareness and personal identity? These questions become even more intriguing when we consider that the branching might not be entirely random. Some interpretations suggest that consciousness itself might play a role in the decoherence process, that the act of observation by conscious beings might influence which branches become real, or at least which branches conscious observers find themselves experiencing. This leads us to one of the most profound implications of the many worlds interpretation. If consciousness does play a special role in quantum decoherence, then perhaps we're not passive observers of reality's branching. Perhaps we're active participants, unconsciously navigating through the maze of parallel possibilities, following paths that lead to coherent, stable experiences of existence. Some physicists have proposed what's called the anthropic principle in relation to quantum branching. The idea suggests that we find ourselves in branches of reality that are compatible with our continued existence and consciousness. In branches where quantum events led to circumstances incompatible with life, there would be no conscious observers to experience those realities. We naturally find ourselves in the subset of branches where things worked out well enough for awareness to emerge and persist. But let's step back and consider how decoherence actually works at the most fundamental level. Imagine a single photon, a particle of light approaching a piece of glass. In the quantum world, this photon doesn't simply bounce off or pass through. Instead, it exists in a superposition of all possible interactions. Part of its wave function corresponds to reflection, part to transmission, part to absorption, and part to scattering in moment. The photon is simultaneously doing various directions, for a brief all of these things. But the moment it interacts with the glass, with the countless atoms and electrons in the material, decoherence begins. The environment of the glass acts like a vast network of quantum detectors, each one slightly different, each one sensitive to different aspects of the photon's state. These environmental interactions happen incredibly quickly. The photon's quantum information spreads into the glass, into the surrounding air molecules, into the thermal vibrations of nearby objects. Within femtoseconds, the coherent superposition is lost. The photon's wave function has effectively split into separate branches, each one corresponding to a different outcome, each one now isolated from the others. In one branch, you observe the photon reflecting off the glass. In another branch, an alternate version of you observes it passing through. In yet another, it's absorbed and converted to heat. Each version of you is convinced that their observation represents the single, definite outcome that actually occurred. None of you can communicate with the others to compare notes. This process is happening constantly, everywhere around you. Every photon hitting your skin, every air molecule colliding with another, every quantum fluctuation in the electromagnetic field is potentially creating new branches of reality. The world you experience is the result of a specific path through this vast labyrinth of quantum possibilities. What makes this even more remarkable is that decoherence isn't a violent process. It's gentle, subtle, almost imperceptible. The quantum coherence doesn't vanish with a bang or a flash. It simply fades away, like morning mist disappearing in sunlight. The superposition doesn't collapse so much as it dissolves, spreading its quantum information throughout the environment until it becomes impossible to recover. Think of it like dropping a single drop of ink into a vast ocean. Initially, the ink is concentrated, visible, distinct, but as it spreads and diffuses, it becomes diluted beyond detection. The ink is still there, but it's now so dispersed throughout the water that it can no longer be distinguished or gathered back together. Quantum coherence behaves similarly, spreading into the environment until it becomes unrecoverable. This environmental spreading of quantum information is what physicists call entanglement with the environment. The quantum system becomes entangled not just with one or two other particles, but with vast numbers of environmental particles. These might be photons, air molecules, thermal vibrations, electromagnetic fields, or any of countless other environmental factors that can interact with quantum systems. Once a quantum system becomes entangled with many environmental particles, the mathematics of quantum mechanics naturally leads to the appearance of classical behavior. The different branches of the wave function become effectively independent, each one evolving according to classical physics, each one creating a distinct reality that feels perfectly normal to its inhabitants. But here's something truly mind-bending to consider. If the many worlds interpretation is correct, then the process of decoherence might be creating not just alternate versions of familiar objects and events, but entirely new physical laws and constants in some branches. Most branches would have physics very similar to ours, but occasionally, quantum fluctuations in the fundamental fields that define physical constants might lead to branches where the speed of light is slightly different, where gravity behaves differently, or where the electromagnetic force has a different strength. These branches with altered physics would likely be short-lived or unable to support complex structures like stars, planets, or life. But they might exist nonetheless, playing out their brief, strange histories in isolation from our more familiar reality. In this view, our universe, with its particular set of physical laws and constants, might be just one island of stability in a vast ocean of quantum possibilities. The implications extend even further when we consider the quantum mechanics of space and time themselves. According to quantum field theory, even empty space is filled with quantum fluctuations, virtual particles popping in and out of existence, brief distortions in the fabric of space-time itself. If these fluctuations are also subject to quantum superposition and decoherence, then perhaps space and time themselves are branching and splitting along with everything else. This could mean that parallel worlds don't just contain different arrangements of matter and energy. They might have different geometries of space and time, different rates of temporal flow, different numbers of spatial dimensions. Some branches might experience time flowing backward, others might have space that curves in impossible ways. Others might have entirely different relationships between cause and effect. Yet within each branch, the inhabitants would experience their reality as perfectly normal and consistent. A being in a universe where time flows backward would perceive their existence as moving forward through time, with causation and memory functioning exactly as they do for us. They would be just as convinced of the reality and normalness of their world as we are of ours. This branching of space-time itself raises profound questions about the nature of existence. If space and time are splitting along with everything else, then what does it mean to say that parallel worlds exist? Exist where? Exist when? The concepts of location and duration that we use to make sense of existence might themselves be artifacts of our particular branch of reality. Perhaps the most unsettling implication is that if decoherence is constantly creating new branches, then the world you experienced just a moment ago, the world in which you began reading this sentence, might already be irretrievably lost. The quantum events that have occurred in your brain and body while processing these words have created new branches, new versions of you with slightly different memories and experiences. The version of you reading these words now is not quite the same as the version that started this paragraph. You share a common history up to a certain point, but quantum decoherence has been constantly splitting your timeline into new branches. Each moment of consciousness might be experienced by a slightly different version of you in a slightly different branch of reality. This doesn't mean your experiences are any less real or meaningful. Each branch, each version of you, experiences their existence as continuous and coherent. Memory provides the illusion of temporal continuity, even as quantum branching creates new versions of yourself with each passing moment. The you reading this sentence feels like the same person who began reading this paragraph, even though you might technically be a descendant of that earlier self, separated by countless quantum branchings. Some physicists have suggested that this constant branching might actually be what creates our experience of the flow of time. Perhaps time doesn't flow at all in any fundamental sense. Perhaps what we experience as temporal progression is actually our consciousness moving along one particular branch of the quantum tree, experiencing a sequence of related but distinct quantum states as a continuous narrative. In this view, the past doesn't exist because it has moved away from us. It exists, but in different branches that we can no longer access due to decoherence. The future doesn't exist because it hasn't happened yet. Rather, it exists as a vast cloud of potential branches that we haven't yet experienced. The present moment is simply the boundary between the branches we've already traversed and the branches that await our exploration. This perspective transforms our entire understanding of memory and experience. When you remember your childhood, when you recall what you had for breakfast this morning, you're not accessing some stored record of past events. You're remembering the experiences of quantum ancestors, earlier versions of yourself who lived in branches that have since become inaccessible through decoherence. Your memories are like fossils, preserved traces of quantum histories that can no longer be directly experienced. This raises fascinating questions about the continuity of consciousness across quantum branches. If you're constantly splitting into new versions of yourself, what maintains the thread of identity that makes you feel like the same person? Perhaps consciousness itself is more resilient than we imagine, somehow maintaining coherence, even as the physical substrate branches and divides. Some researchers have proposed that consciousness might have quantum properties that allow it to navigate or influence the branching process. This isn't to suggest anything mystical, but rather that the complex information processing that creates awareness might be sensitive to quantum coherence in ways we don't yet understand. Your brain, after all, is a quantum system subject to all the same superposition and decoherence effects as any other physical object. The neurons in your brain are constantly undergoing quantum processes, electrons tunneling across synapses, photons absorbed by visual pigments, molecular conformations shifting between quantum states. Each of these events might be creating new branches of reality, new versions of your ongoing stream of consciousness. Yet somehow, out of this quantum chaos emerges the stable, coherent experience of being you. Your thoughts feel continuous, your memories feel consistent, your sense of self feels unbroken. This suggests that consciousness might be remarkably robust against quantum decoherence, able to maintain its essential characteristics even as it branches into countless parallel streams. But let's consider what this means for the nature of choice and free will. In a classical universe, when you decide between chocolate and vanilla ice cream, you're making a single choice that determines a single outcome. But in a branching quantum multiverse, every possible choice you could make is actually being made by some version of you in some branch of reality. Right now, as you listen to these words, countless versions of you are making different decisions. Some have paused to make tea, others have chosen to listen to different videos entirely. Still others have decided to take a walk instead. Every possible choice that could emerge from the quantum processes in your brain is being actualized somewhere in the vast tree of parallel realities. This doesn't mean your choices don't matter. They absolutely do, but perhaps not in the way we traditionally think. Your choices don't determine what happens in the multiverse as a whole, because everything that can happen does happen somewhere. Instead, your choices determine which branch of reality you experience, which path through the quantum maze your consciousness follows. In this sense, free will becomes less about controlling outcomes and more about navigation. You're not choosing what exists, you're choosing what you experience. Every decision is like selecting a path through an infinite garden of forking possibilities, each one leading to a different version of your future self. The implications extend beyond individual choice to encompass the entire nature of causation. In our everyday experience, causes seem to lead directly to effects. You flip a light switch, yet the light turns on. You drop a glass, it falls and breaks. But in a quantum multiverse, causation becomes far more subtle and complex. Every cause is simultaneously producing every possible effect in different branches. When you flip that light switch, in most branches the light turns on as expected, but in some branches, a quantum fluctuation in the electrical system causes it to fail. In others, a cosmic ray happens to strike a crucial component at just the right moment to create an entirely different outcome. The version of you reading this experiences the branch where causation appears to work normally, but countless other versions are experiencing branches where the unexpected occurred. The feeling that causes reliably led to effects is itself a kind of selection bias. You naturally find yourself in branches where the world behaves in ways that allow for continued existence and coherent experience. This leads us to one of the most profound aspects of quantum decoherence and parallel worlds: the role of observers in creating reality. Not in the sense that consciousness literally creates the physical world, but rather that conscious observers naturally find themselves in branches of reality that are compatible with their continued existence and awareness. Consider the anthropic principle again, but now in the context of constant quantum branching. In most branches of reality, conditions might not be suitable for the emergence or continuation of consciousness. Perhaps quantum fluctuations in stellar fusion rates prevent stars from forming. Perhaps variations in fundamental constants make chemistry impossible. Perhaps random quantum events in biological systems prevent life from developing complexity. But conscious observers can only find themselves in branches where consciousness is possible. This creates a kind of observational selection effect. The reality you experience seems fine-tuned for life and awareness, not because it was designed that way, but because you can only observe branches where such fine-tuning occurred by chance. This principle might extend to much smaller scales as well. Every moment, quantum events in your brain could potentially lead to branches where your neural processes become incoherent or non-functional. But your continued consciousness ensures that you only experience branches where your brain continues to work normally. From your perspective, your mental processes seem remarkably stable and reliable, but this might be because you can only observe branches where they remain so. The mathematics behind decoherence reveals just how quickly and thoroughly quantum coherence is lost in complex systems. When physicists calculate the decoherence time for a human brain, they find that quantum coherence would be lost in less than a trillionth of a second. The warm, wet, electrically active environment of neural tissue is incredibly efficient at destroying quantum superposition. This rapid decoherence explains why we don't experience quantum weirdness in our mental processes. By the time a thought forms, by the time consciousness recognizes an experience, countless decoherence events have already occurred. The quantum fuzziness that might have existed at the molecular level has been smoothed away, leaving us with the crisp, definite experiences that characterize normal awareness. Yet this same decoherence might be creating vast numbers of parallel branches up of consciousness. Each quantum event in your brain, each molecular collision that could go one way or another, might be spawning alternate versions of your ongoing mental processes. Most of these alternates would be virtually identical to your current experience, differing only in microscopic ways that don't affect conscious awareness. But occasionally, larger differences might accumulate. A different pattern of quantum events in your memory systems might lead to a slightly different recollection. A variation in neurotransmitter release might create a subtly different emotional response. A quantum fluctuation in your decision-making circuits might lead to an alternate choice. All of these possibilities are simultaneously being realized in different branches of reality. The version of you experiencing this particular stream of consciousness is just one path through an incomprehensibly vast tree of parallel mental processes. This branching extends beyond individual minds to encompass all the complex systems that make up our world. Whether systems, with their sensitive dependence on initial conditions, are constantly branching into alternate climate patterns. Ecological systems, driven by countless random interactions between organisms, are exploring different evolutionary pathways in different branches. Even geological processes, seemingly so slow and deterministic, are subject to quantum branching. Radioactive decay events in rocks, cosmic ray interactions with minerals, quantum fluctuations in gravitational fields, all contribute to the constant splitting of geological reality into parallel versions. The Earth you experience, with its particular configuration of continents and oceans, its specific pattern of mountain ranges and river systems, is just one branch among countless others. In some branches, different patterns of volcanic activity created alternate landscapes. In others, different sequences of cosmic impacts shaped the planet's surface in different ways. Yet all of these parallel Earths feel equally real to their inhabitants. Each supports its own version of natural history, its own evolutionary pathways, its own emergence of consciousness and civilization. The dinosaurs that went extinct in our branch might still roam in others. The ice ages that shaped our continents might have followed different patterns elsewhere. This constant branching creates what might be called a quantum archaeology. Every moment that passes, every quantum event that occurs, is preserving alternate versions of history in parallel branches. Nothing is truly lost in a quantum multiverse because every possibility that could have occurred is being preserved somewhere in the vast tree of parallel realities. Your childhood exists not just in your memories, but in actual parallel branches where earlier versions of you are still living those experiences. Your ancestors continue their lives in branches that split off before their deaths. Every moment of history, every possible variation of events, is being played out simultaneously across the infinite expanse of parallel worlds. This preservation of all possibilities raises profound questions about the nature of loss and tragedy. In our branch of reality, we experience events as unique and irreversible. When someone dies, when something beautiful is destroyed, when opportunities are missed, we feel the weight of permanent loss. But in a quantum multiverse, nothing is truly permanent or irreversible. Every person who has died continues living in branches that split off before their death. Every beautiful thing that has been destroyed remains intact in alternate realities. Every missed opportunity is being pursued by alternate versions of ourselves in parallel branches. This doesn't diminish the reality of loss and tragedy in our particular branch. The pain of separation, the grief of endings, the regret of missed chances are all completely real and valid experiences. But it does suggest that existence itself is far more resilient and complete than our limited perspective allows us to see. Perhaps the most beautiful aspect of quantum decoherence is how it allows for both unity and diversity. At the deepest level, all the parallel branches spring from the same underlying quantum reality. We share a common origin with all our alternate selves, all the parallel worlds, all the different versions of history and possibility. Yet decoherence allows for an infinite flowering of diversity. Every possible variation, every conceivable alternative, every potential path through the space of possibilities is being explored simultaneously. The multiverse is like a vast garden where every seed that could possibly sprout is sprouting, where every flower that could possibly bloom is blooming. In this grand quantum garden, you are both unique and universal. Unique because your particular path through the branching possibilities has created a specific, irreplaceable experience of existence. Universal because you share deep quantum connections with countless alternate versions of yourself and with all the other conscious beings exploring their own paths through the maze of possibilities. As we drift deeper into this exploration of parallel worlds and quantum decoherence, it becomes clear that reality is far stranger, far richer, and far more wondrous than our everyday experience suggests. The solid, definite world we perceive is just the tip of an incomprehensibly vast iceberg of quantum possibilities. Every moment you experience is both precious and eternal. Precious because it represents your unique path through the quantum maze, your particular perspective on the infinite garden of possibilities. Eternal because it exists forever in its own branch of reality, preserved for all time in the vast archive of parallel worlds. The universe you inhabit is just one note in an infinite symphony of parallel realities. Each one as real and meaningful as your own. And in this gentle recognition lies perhaps the deepest comfort of all, that existence is so much larger, so much more complete, so much more wonderful than any single perspective can contain. The elegant mathematics of quantum decoherence reveals something truly remarkable about the nature of measurement itself. When we think of measurement in everyday terms, we imagine it as a passive process, like reading a thermometer or checking the time on a clock. But in the quantum worlds, measurement is far more active and creative than we ever imagined. Every time you observe something, every time light from an object reaches your eyes, every time your instruments detect a quantum property, you're not simply recording what was already there. You're participating in the creation of a specific branch of reality. The act of measurement doesn't reveal pre-existing properties so much as it crystallizes one particular outcome from a cloud of quantum possibilities. Consider what happens when you look at a distant star. The photons reaching your eyes left that star years ago, carrying quantum information about its state. But during their journey through space, these photons existed in superposition, simultaneously taking every possible path through the cosmos. Some paths led through regions of space with slightly different gravitational fields, others through areas with varying densities of interstellar dust, others through quantum fluctuations in the vacuum itself. When these photons finally reach your retina, decoherence occurs almost instantaneously. The quantum superposition collapses, not into a single outcome, but into multiple branches. In one branch, you see the star with a particular brightness and color. In another branch, an alternate version of you sees it slightly differently due to different quantum interactions along the light's path. Each version of you is convinced they're seeing the star as it truly is. This process extends to every aspect of perception and measurement. When you touch a surface and feel its texture, quantum interactions between the atoms in your fingertips and the atoms in the material are creating branching realities. The particular pattern of neural signals that creates your sensation of roughness or smoothness is just one path through a vast space of quantum possibilities. The instruments scientists use to probe the quantum world are themselves subject to this same branching process. When a particle detector registers the presence of an electron, it's not simply recording a pre-existing fact. The detector, the electron, and the entire experimental setup are becoming quantum entangled, creating multiple branches where different measurement outcomes occur. This has profound implications for our understanding of scientific knowledge itself. Every experiment, every observation, every measurement that has ever been made has created branching realities. The scientific facts we take for granted, the constants we've measured, the theories we've confirmed, all exist in our particular branch of the quantum multiverse. In other branches, slightly different measurements might have led to different scientific conclusions. This doesn't mean science is arbitrary or unreliable. Within each branch, the laws of physics remain consistent and predictable, but it does suggest that scientific knowledge itself is branch dependent. The version of physics you learned in school, the value of fundamental constants, the experimental results that shaped our understanding of nature, all correspond to one particular path through the quantum maze of possibilities. In some branches, the slight variations in measurement outcomes might have led scientists to different theories entirely. Perhaps in one branch, a crucial experiment gave a result that was just barely within the margin of error, leading researchers down a different theoretical path. Maybe in another branch, a random equipment malfunction during a key experiment prevented an important discovery, delaying scientific progress by decades. Yet in each branch, the inhabitants would be convinced that their version of science represents the true understanding of nature. They would have their own textbooks, their own Nobel Prize winners, their own history of scientific breakthroughs and paradigm shifts. Each branch would feel like the natural, inevitable progression of human understanding. The branching nature of quantum measurement also affects our understanding of consciousness and free will in subtle but important ways. When you make a decision, when you choose between alternatives, your brain is essentially performing a quantum measurement on itself. The neural processes that lead to choice involve countless molecular interactions, each potentially subject to quantum uncertainty. As your neurons fire and your thoughts crystallize into decisions, decoherence is constantly occurring throughout your brain. Different patterns of neural activity, different sequences of molecular events, different outcomes of quantum processes in your synapses are all creating branching possibilities for your mental state. The choice you experience making is real and meaningful within your branch of reality. But countless alternate versions of you are simultaneously making different choices based on different quantum outcomes in their neural processes. Your sense of agency, your feeling of deliberate decision-making, is preserved in each branch, even as the multiverse explores every possible choice you could make. This creates a fascinating paradox of freedom and determinism. From the perspective of the multiverse as a whole, everything that can happen does happen. Every possible choice is made. Every potential decision is actualized. Every conceivable outcome occurs somewhere. In this sense, the future is completely determined by the branching structure of quantum possibilities. But from the perspective of your individual branch, your choices matter enormously. They determine which path through the quantum maze your consciousness follows, which version of the future you experience, which of the infinite possible selves you become. Free will exists not as the ability to control the multiverse, but as the power to navigate through it. The implications extend beyond individual choice to encompass the entire evolution of consciousness itself. Every moment of awareness, every flash of insight, every creative breakthrough that has ever occurred in any conscious being has potentially created branching realities. The thoughts you're thinking right now as you process these ideas are spawning alternate versions of your mental state. In some branches, Quantum fluctuations in your neural networks are leading to slightly different interpretations of these concepts. Perhaps in one branch, a different pattern of synaptic activity is causing you to have a sudden insight about the nature of reality. In another, a variation in neurotransmitter levels is creating a different emotional response to these ideas. All of these alternate streams of consciousness are equally valid, equally real, equally meaningful. The particular sequence of thoughts and feelings you're experiencing is just one thread in a vast tapestry of parallel mental processes, all springing from the same quantum source, but exploring different possibilities of awareness and understanding. This branching of consciousness raises profound questions about the nature of identity across time. The person you were yesterday, with their particular thoughts, feelings, and experiences, exists in branches that have become inaccessible through quantum decoherence. The person you'll be tomorrow will emerge from quantum processes that haven't yet occurred. Yet somehow, through all this branching and splitting, something maintains continuity. Call it consciousness, call it awareness, call it the thread of identity that makes you feel like the same person from moment to moment. This continuity persists even as your physical substrate constantly branches into parallel versions. Perhaps consciousness is like a river flowing through the landscape of quantum possibilities. The river maintains its essential character, its direction, and purpose, even as it splits around islands and obstacles. Each branch of the river is still the same river, carrying the same water, following the same fundamental course, even though they flow through different terrain. Your consciousness might be flowing in the same way through the branching landscape of quantum reality. Each branch maintains the essential character of your awareness, your memories, your personality, your ongoing stream of experience, even though they unfold in slightly different quantum contexts. The environmental factors that drive decoherence are themselves part of this branching process. The air molecules colliding with quantum systems, the photons scattering off surfaces, the thermal vibrations that destroy quantum coherence. All of these are simultaneously creating and being created by the branching structure of reality. This creates what physicists call a self-consistent branching process. The environment that causes decoherence is itself undergoing decoherence, creating branches where environmental conditions are slightly different. These different environmental conditions then lead to different patterns of decoherence, creating a complex feedback loop of quantum branching. Imagine watching snowflakes fall during a winter storm. Each snowflake follows a unique path through the air, shaped by tiny air currents, temperature variations, and random collisions with other particles. But these same air currents and temperature variations are themselves being influenced by the passage of the snowflakes. The system creates itself as it evolves, with each element both shaping and being shaped by all the others. Quantum decoherence works in a similar way, but with far greater complexity and subtlety. Every quantum system is both an observer of other systems and an observed system itself. Every environmental interaction that causes decoherence is itself a quantum process subject to superposition and branching. This self-referential nature of quantum branching creates what might be called a bootstrap universe, where reality pulls itself up by its own quantum bootstraps. The branches don't exist in some pre-existing space of possibilities. They create the space of possibilities as they branch, defining the very structure of reality through their own existence. The speed and scale of this process are almost beyond comprehension. Every particle interaction, every quantum field fluctuation, every moment of environmental entanglement is potentially creating new branches. The number of parallel worlds might be growing exponentially, doubling or tripling or increasing by vast factors with every passing instant. Yet this exponential growth doesn't lead to chaos or incoherence. Instead, it leads to an ever richer tapestry of possibilities, an ever more complete exploration of what existence can be. Each new branch adds to the total inventory of realized possibilities, ensuring that nothing that can exist goes unexplored. Some physicists have calculated that even simple quantum systems might create astronomical numbers of branches in very short periods of time. A single atom in thermal equilibrium with its environment might spawn millions of parallel versions of itself every second. A molecule interacting with light might create billions of branches during a single quantum transition. Scale this up to the complexity of biological systems, of brains, of entire ecosystems, and the numbers become truly staggering. Your body, with its trillions of atoms all undergoing quantum processes, might be creating more new branches of reality each second than there are stars in the observable universe. This constant creation of parallel worlds doesn't require enormous amounts of energy or exotic physics. It emerges naturally from the ordinary quantum processes happening everywhere around you. The same quantum mechanics that explains how computer chips work, how lasers operate, how photosynthesis captures sunlight, is also potentially creating infinite varieties of parallel realities. The elegance of this process lies in its simplicity. You don't need special conditions or unusual circumstances for parallel worlds to branch off. They emerge automatically from the normal evolution of quantum systems interacting with their environments. Reality branches not because something dramatic happens, but because ordinary quantum mechanics unfolds exactly as the equations predict. This ordinariness of extraordinary phenomena is one of the most beautiful aspects of quantum decoherence. The most mind-bending implications of modern physics arise not from exotic extremes, but from the gentle, everyday interactions between quantum systems and their surroundings. Parallel worlds, if they exist, are born from the mundane miracle of molecules bumping into each other. The philosophical implications of this ordinariness are profound. If parallel worlds are real, they're not hidden in some distant realm, accessible only through advanced technology or mystical practices. They're right here, right now, emerging from the same physical processes that make your computer work, that allow plants to grow, that enable your neurons to fire. This suggests that the boundary between the ordinary and the extraordinary might be far thinner than we imagine. The solid, predictable world of everyday experience might be floating on an ocean of infinite quantum possibilities, connected to countless parallel realities by the invisible threads of quantum entanglement and decoherence. Every breath you take, every step you walk, every word you speak is potentially creating ripples in this ocean of possibilities. Not dramatic, earth-shaking ripples, but gentle, subtle influences that propagate through the quantum substrate of reality, perhaps connecting your branch to others in ways too delicate to detect. The quantum vacuum itself, the supposedly empty space between particles, is filled with virtual particles and quantum fluctuations that might be contributing to this branching process. Even in the deepest void, far from any matter or energy, quantum fields are constantly fluctuating, creating and annihilating particle pairs, generating the quantum noise that might be seeding new branches of reality. This means that truly empty space might not exist in a quantum multiverse. Every region of space-time, no matter how void of matter, is alive with quantum activity that could be spawning parallel worlds. The universe is not just full of things, it's full of possibilities, each one potentially becoming real in some branch of the ever-expanding tree of parallel realities. As we drift deeper into these contemplations, the implications become both more abstract and more intimate. Abstract because they challenge our most basic assumptions about the nature of existence, time, and identity. Intimate because they suggest that your personal experience of consciousness and choice is connected to the deepest structures of physical reality. The quantum decoherence happening in your brain right now as you process these thoughts is part of the same fundamental process that governs the behavior of distant galaxies and subatomic particles. Your inner world of thoughts and feelings is not separate from the outer world of physics and cosmology. They're different aspects of the same quantum tapestry, different expressions of the same underlying reality. This unity of inner and outer, of consciousness and cosmos, of the personal and the universal, might be the most profound gift that quantum decoherence offers to our understanding. It suggests that you are not an isolated observer of reality, but an integral part of its ongoing creation. Every moment of your existence participates in the universe's endless exploration of what is possible. The parallel worlds branching off around you are not foreign territories populated by strangers. They're alternate expressions of the same underlying existence that you embody. Your alternate selves in other branches are not other people, but other facets of the same fundamental identity, exploring different paths through the quantum maze of possibilities. In this sense, the many worlds interpretation offers not just a scientific theory, but a kind of cosmic comfort. It suggests that existence is far more robust, far more complete, far more forgiving than our limited perspective allows us to see. Nothing is truly lost because every possibility is preserved somewhere. No potential goes unrealized because all potentials are being explored simultaneously. The loneliness that sometimes accompanies human consciousness, the feeling of being isolated in your own private experience, dissolves in the recognition that countless versions of that same consciousness are sharing the journey through parallel realities. You are never truly alone because you are part of an infinite community of selves, all connected by quantum threads that transcend the apparent boundaries between worlds. As the mathematics of decoherence unfolds its elegant implications, it reveals a universe that is simultaneously one and many, finite and infinite, determined and free. These apparent contradictions resolve in the gentle recognition that reality is large enough to accommodate all possibilities, generous enough to explore every potential, and mysterious enough to remain forever surprising. The next time you make a choice, the next time you observe the world around you, the next time you experience a moment of consciousness, remember that you might be participating in one of the most profound processes in all of existence, the ongoing creation of parallel worlds through quantum decoherence. You are not just living your life, you are helping to weave the infinite tapestry of what reality can be. Perhaps the most astonishing aspect of quantum decoherence is how it transforms our understanding of time itself. In our everyday experience, time feels like a river flowing in one direction, carrying us from past to future in an irreversible current. But in a universe where quantum branching is constantly occurring, time might be more like a vast delta, splitting into countless streams that flow in parallel, each one carrying different versions of history toward different versions of tomorrow. Consider what this means for the nature of memory. When you remember your first day of school, that birthday party from childhood, or the conversation you had yesterday, you might think you're accessing stored records of past events. But if quantum decoherence is constantly creating new branches, then those memories might be something far more mysterious. They could be quantum fossils, preserved traces of experiences that occurred in branches that have since become inaccessible to you. The child who experienced that first day of school exists now only in branches that split off years ago. The version of you who had that conversation yesterday lives in a branch that's separated from yours through countless quantum events since then. Your memories are not just records of your past, but bridges to alternate versions of yourself who lived those experiences in quantum realities that you can no longer reach. This creates a haunting beauty in the nature of remembrance. Every cherished memory, every moment of joy or sorrow that shaped you, continues to exist, not just in your recollection, but as living reality in parallel branches where those moments are still unfolding. The grandmother who passed away years ago continues her life in branches that diverged before her death. The pet you loved as a child still plays in quantum realities, where different molecular events led to different outcomes. Yet this preservation comes with a gentle melancholy. The branches containing those precious moments are forever separated from you by the one-way membrane of quantum decoherence. You can remember them, treasure them, carry their influence forward in your current branch, but you can never return to them or interact with them again. They exist in a quantum yesterday that is as real as your quantum today, but as unreachable as a distant star. The branching nature of quantum time also affects how we understand causation across different scales of existence. On the molecular level, quantum events are creating microscopic branches that usually have no noticeable effect on larger scale phenomena. A single electron taking one path instead of another rarely influences the behavior of the atom it belongs to, let alone the molecule, the cell, the organism, or the ecosystem. But occasionally, these microscopic quantum events can cascade upward through the scales of organization. A quantum fluctuation in a crucial protein molecule might alter a biochemical reaction. That altered reaction might change the behavior of a cell. The changed cell might influence tissue function. The altered tissue might affect organ performance. The modified organ might change an organism's behavior, and that behavioral change might ripple outward to affect entire ecosystems. These quantum butterfly effects create branches where small changes at the microscopic level lead to dramatically different outcomes at macroscopic scales. In one branch, a quantum event in a single neuron leads to a slightly different thought pattern, which influences a decision, which changes a life trajectory. In another branch, a quantum fluctuation in photosynthetic machinery alters plant growth patterns, which shifts ecological balances, which affects climate patterns over decades or centuries. The mathematical beauty of this multi-scale branching lies in its fractal nature. Just as a coastline looks similarly jagged, whether you view it from a satellite or examine it with a magnifying glass, the branching structure of quantum reality exhibits similar patterns across all scales of space and time. Quantum decoherence creates tree-like structures at the level of individual particles, molecules, organisms, ecosystems, planets, solar systems, and galaxies. Each level of organization has its own characteristic timescale for decoherence. Individual particles lose quantum coherence in femtoseconds or picoseconds. Molecules might maintain coherence for nanoseconds or microseconds. Living cells typically decohere in milliseconds. Complex organisms like humans lose quantum coherence almost instantaneously on biological timescales. But larger systems, like weather patterns or ecological networks, might maintain certain types of quantum coherence for much longer periods. This hierarchy of decoherence timescales creates a beautiful symphony of branching at different frequencies. High-frequency quantum events at the particle level create rapid, fine-grained branching that usually has little effect on larger scales. Medium-frequency events at the molecular level create more substantial branches that can influence biological processes. Lower-frequency events at the cellular and organismal level create the major branches that shape individual lives and experiences. The interplay between these different scales of branching might explain why consciousness feels both stable and dynamic. Your sense of personal identity remains remarkably consistent, even though the quantum substrate of your brain is branching trillions of times per second. The high-frequency quantum branching creates mostly similar versions of your mental state, while the lower-frequency branching occasionally creates more significant variations in thought and experience. This multi-scale perspective also illuminates the relationship between quantum mechanics and classical physics. Classical behavior emerges not because quantum mechanics stops applying to large objects, but because large objects undergo such rapid and thorough decoherence that their quantum branching becomes effectively invisible. A baseball thrown through the air is simultaneously following countless quantum trajectories, but decoherence happens so quickly that each branch contains a baseball following a nearly identical classical path. The classical world we experience is not separate from quantum reality, but rather represents a particular kind of quantum behavior. It's what quantum mechanics looks like when decoherence has smoothed away most of the branching variations, leaving us with the appearance of single, definite outcomes. Classical physics is quantum physics viewed through the lens of rapid decoherence. This perspective transforms our understanding of physical laws themselves. The equations of motion that govern classical objects, the thermodynamic principles that describe energy flow, the electromagnetic relationships that power our technology. All of these might be statistical descriptions of quantum branching processes. What we perceive as fundamental laws might actually be emergent patterns arising from the underlying quantum branching of reality. In some branches, quantum fluctuations might occasionally violate these statistical laws in small ways. A ball might spontaneously gain energy, heat might flow from cold to hot, or electromagnetic fields might behave unexpectedly. But these violations would be so rare and so quickly overwhelmed by decoherence that they would be undetectable within any single branch. The apparent universality of physical laws emerges from the statistical behavior of quantum branching rather than from some more fundamental level of reality. This statistical emergence of classical laws has profound implications for our understanding of scientific knowledge. The experiments that confirmed our theories, the measurements that determined fundamental constants, the observations that shaped our models of reality, all occurred within the context of rapid quantum decoherence. Our scientific understanding describes not absolute truths about reality, but rather the statistical patterns that emerge from quantum branching within our particular region of the multiverse. In branches where quantum fluctuations led to slightly different experimental outcomes, scientists might have developed different theories to explain their observations. The speed of light might have been measured differently due to quantum variations in measurement apparatus. The value of Planck's constant might have been determined to be slightly different because of quantum fluctuations in the detectors used to measure it. The laws of thermodynamics might have been formulated differently based on quantum variations in the systems used to study energy flow. Yet within each branch, the scientific method would work exactly as it does in our branch. Theories would make predictions, experiments would test those predictions, and scientific knowledge would advance through the same rigorous process of hypothesis and verification. Each branch would develop its own internally consistent understanding of reality based on the quantum events that shaped its particular history of scientific discovery. This multiplicity of scientific realities doesn't diminish the value or reliability of science within any given branch. The scientific method remains the most powerful tool we have for understanding the patterns and relationships that govern our particular version of reality. But it does suggest a kind of humility about the absolute nature of scientific truth. Our science describes our branch of the quantum multiverse with remarkable accuracy, but it might not be the only possible science. The branching nature of scientific knowledge extends beyond physics to encompass all fields of inquiry. In branches where quantum events influence the development of different technologies, the history of invention might have unfolded differently. Perhaps in one branch, quantum fluctuations in early computer circuits led to different approaches to information processing. In another, random variations in biological systems led scientists to different insights about the nature of life. Even mathematics itself might be subject to this quantum branching. While mathematical truths seem absolute and universal, the particular path by which human minds discover and formulate these truths is influenced by countless quantum events in the brains of mathematicians. Different patterns of neural activity might lead to different ways of thinking about mathematical relationships, different notations for expressing mathematical ideas, different sequences of mathematical discoveries. In most branches, these variations would be minor. The fundamental relationships described by mathematics would remain the same, but they might be expressed differently, discovered in different orders, or organized according to different conceptual frameworks. The deep structure of mathematical truth would be preserved across branches, but its surface manifestations might vary in fascinating ways. This suggests that even our most abstract and seemingly universal forms of knowledge are intimately connected to the quantum processes occurring in conscious minds. The thoughts you're thinking right now, the way you're processing and understanding these concepts, the particular sequence of insights and questions arising in your awareness, all of these are being shaped by quantum events in your neural networks. As you contemplate the nature of parallel worlds, countless versions of you in other branches are having slightly different thoughts about the same concepts. Some might be reaching different conclusions, others might be making different connections, still others might be experiencing different emotional responses to these ideas. The particular understanding you develop will be unique to your branch, even though it springs from the same underlying quantum substrate as all the others. This personal dimension of quantum branching might be the most intimate and immediate way to understand the implications of parallel worlds. You are not just an observer of quantum decoherence, you are a participant in it. Every moment of your conscious experience is both the product of quantum branching and a contributor to future branching events. The decisions you make, the thoughts you think, the emotions you feel, all of these emerge from quantum processes in your brain and nervous system. But they also influence future quantum events by creating the neural and biochemical context in which those events occur. Your consciousness is simultaneously being created by quantum decoherence and helping to shape the pattern of future decoherence events. This creates a beautiful recursive relationship between mind and quantum reality. Your thoughts are products of quantum branching, but they also help determine which branches your future self will experience. You are both the result of quantum processes and an active participant in guiding those processes toward particular outcomes. The implications extend beyond individual consciousness to encompass all forms of information processing in the universe. Every time information is copied, transmitted, processed, or stored, quantum decoherence is potentially creating branching realities. The DNA replication occurring in your cells right now is subject to quantum uncertainty at the molecular level. Different quantum outcomes during base pairing might create slightly different versions of your genetic code in different branches. Over time, these small genetic variations might accumulate into more significant differences. In some branches, different patterns of gene expression might lead to slightly different physical characteristics. In others, variations in neural development might result in different cognitive abilities or personality traits. The biological you that exists in each branch would be recognizably you, but with subtle variations that reflect the quantum history of that particular branch. This genetic branching extends across generations and species. Every act of reproduction, every mutation event, every instance of genetic recombination is potentially creating new branches of biological reality. The evolutionary history of life on Earth might be unfolding differently in each branch, with different species emerging, different ecological relationships forming, different solutions to the challenges of survival and reproduction. And so we come to the end of our gentle journey through the quantum maze of parallel worlds and hidden realities. We've explored the elegant mathematics of decoherence, witnessed the constant branching of possibilities, and glimpsed the infinite garden where every potential version of existence blooms simultaneously. Whether these parallel worlds are real or simply beautiful mathematics, they remind us that reality is far stranger and more wondrous than our everyday experience suggests. As you drift off tonight, remember that in some branch of the quantum multiverse, another version of you is just beginning to dream. Sleep well, and thank you for sharing this quiet exploration of the cosmos with me.